Hello everyone, my name is Sandeep Patel and I welcome you all to the brand new series of Big Data with Apache Spark. Before getting into Apache Spark, we should be aware about what is Big Data because that is the problem which Apache Spark is going to solve. So in our today's video, that's what we are going to do. We are going to talk about what is Big Data, and these are some points which we are going to cover: starting and ending limit, 5 V's, challenges and domains in which Big Data is used. So without wasting any time, let's start with the very first topic, which is what is big data? Whenever we talk about big data, the only thing which comes into our mind is huge amount of data. If the amount of data is huge, then we'll call that data as big data. But what exactly do we mean by huge? Because different computers have different hard disk, different computers have different processing power. So what exactly is this big and from where it will start? Let's take simple example. I have a laptop which has 1 terabyte of storage capacity. If I say my laptop is currently storing 100 gigabytes, then that's not at all a big data for my computer or my laptop. That's not a big data, right? However, if I say I want to store now 959 gigabytes, now each and every drive is turning red, this much amount of data, now my laptop will start facing problem because of size of data at 959 GB. That's why 959 GB is going to be big data for my laptop. If there is any laptop which has storage capacity of 5 terabytes, even 959 gigabytes is not going to be a problem for that laptop. Okay, so what we understand here is the amount of data at which our current implementation or our current systems start facing issues, then that amount is going to be big data for us. These things might confuse us, so let's try to understand the starting limit and ending limit of big data. As we discussed earlier, the amount of data at which we will start facing problems is going to be the starting limit. Normally, when it comes to current hardware level implementations in industries, terabytes and petabytes of data is the limit. Normally, when total amount of data crosses certain terabytes or certain petabytes, then the system runs into the problem of big data. So this is the starting limit. When it comes to ending limit, there is no ending limit to big data. It's not like, okay, after a certain limit, we'll call it humongous data or tremendous data. No, big data is big data. Once you start facing problems, any data beyond that limit is going to be big data. Most of the times whenever we talk about big data, we only think about size. But size is not the only characteristic of big data. Of course, it is the most important characteristic of big data, that big data has huge volume, it has huge size. Of course, it is an important characteristic, but that's not the only characteristic. Big data might also have speed. Speed means velocity. So that's the second V, velocity. Let's take example Twitter. In 1 second, 10,000 tweets get generated. So you have to work with that much amount of data. You have to ingest that data into your system, process it, produce the results. So that's huge speed. Then comes variety. Data is getting generated, of course, but data is not just getting generated into one format. It can be generated into multiple formats. So there are different types of data, like structured data, semi-structured data, unstructured data. I know, let's try to understand what structured data, semi-structured data and structured data is. So let's talk about structured data first. So structured data is like what you are seeing here, is like a good student, right? Data is properly structured into the format of rows and columns. That's what we call structured data. Not just it is arranged into the format of rows and columns. Every column has its own data type. As we can see here, roll number is accepting only integers. If you try to write something like Dark Knight Rises in the roll number column, you won't be able to write it. It won't accept in the first place. This type of data is called as structured data. Structured data has structure as well as schema. If you take example, the example is going to be your MySQL table is going to be the good example for structured data. Let's now talk about semi-structured data. Semi-structured data, as you can see in front of your eyes, it's a comma separated file. It's a comma separated data, right? You can call it semi-structured data. Now, why we can call it semi-structured data? As you can see, there is a small structure over here that each and every field is separated by comma. And if you have schema, you can convert this into structured. So semi-structured is like you can convert it to structure, or there is certain structure to your data. However, if I want to remove roll number 2 and instead of roll number 2, I want to write Mission Impossible, I can write it without any issue. In a normal CSV file, you can do it without any problem. In this case, in case of semi-structured data, we have structure, but we don't have schema. That's called semi-structured data. As you can see here, we have structure, but we don't have schema in case of semi-structured data. Few examples are CSV, TSV, JSON file, XML file. These are examples of semi-structured data. Then there is this unstructured data. Unstructured data is like there is no structure and there is no schema. Just I'm opening a file and I'm writing out whatever is in my mind. I write these things down and I simply save it and close it. There is no structure, there is no schema. If you see examples below, there are few examples like raw text file, audio file, video file, images. These come under your unstructured data. So these are three broad categories of data. It comes under variety. So whenever data is getting generated, it can be getting generated into any of these formats. The next V is veracity. Veracity refers to inconsistency. If data is getting generated at very high speed, there is too much data, huge amount of data is present. So there are chances that data might have some corrupt values, and these corrupt values can mess up our final results, and that's what we don't want. And if the amount of data is used, there are high chances that there might be some inconsistencies. So this is also one of the characteristic of big data. The final characteristic of big data is value. See, value is something, you're getting something out of big data. That's why you're dealing with all these volume, velocity, variety, veracity. Why should we deal with these things? If you have so many problems in big data, you have huge volume, huge velocity, then don't process it, don't work on it. Why are we working? Because there is value hidden inside that big data, and if there is a person who can extract the value out of that data, then that is going to be a big hit. Now let's try to understand this. What could be the value? Value is any information which can improvise your business, any information using which the companies can earn money. That is value. Let's talk about challenges, everyone. Whenever we hear the word challenge, our ego gets a boost. So there are a number of challenges for big data as well. The very first challenge for big data is going to be the storage part. Let's say I have one application, I have hosted it on server, that application is now generating data. That data is getting stored onto the hard drive of my server, and that hard drive is constantly getting filled. At one point, my hard drive will be insufficient to store that much amount of data. So I'm getting into big data. I have started to face the problems associated with it. When amount of data gets increased, storage becomes difficult. Second challenge is processing. See, storage is like, it can be manageable. You can write data onto magnetic tapes. You can store them into archives. You can store it into external hard drives. You can manage it, but whenever it comes to processing, so what is data processing exactly? I'm going to give you one use case. Let's try to understand this. I have weather data of 2022 and the size of that data is 2000 gigabytes and I want to calculate something out of it. So I have to run a query or I have to write the code, and that code or that query is going to run on this 2000 gigabytes of data and it is going to bring some results to us. It can also be like eliminating the corrupt values from this data set. It can also be transforming this data set. There might be different use cases which come under processing. So if the amount of data is huge, processing will also get difficult. Then there are several problems like security. If amount of data is huge, then it's hard to provide security. But nowadays there are mechanisms using which security can be provided. Plus curation. Curation means, let's say, before 10 to 12 years in my country, we used to run Facebook. Say right now also there are many people on Facebook, but before 10 to 15 years, that was a different story. So we have some weird photos posted on Facebook. Say we were young and I was also young. I thought that let's post something which will make me look cool. And I posted that stuff and I was looking like a fool. I should do rap sometimes. So I have posted those videos. Now also if you visit my timeline, those photos are still there. However, I have made them private so that I should not be embarrassed in front of a number of people. So I have made them private, but the Facebook has stored those photos. Why Facebook has to store those photos? There is nothing, at least from my point, those are not important for me. But from the Facebook point of view, they might be important. So you might have to store data for longer periods of time. That's called curation. Curation means storing data for longer periods of time. This is also one challenge with big data. If you want to store data for longer periods of time, you can't free up your hard drives. You have to keep that data into storage. Okay, it's not like these are the only challenges. There are a number of challenges, but these are some challenges which are most commonly faced challenges, we can say. Last point for our today's video. After this, you are going to enjoy your freedom, right? Domains in which big data is used. So there are n number of domains in which big data is used. I have just listed few domains only. Oh, okay, on this side, I have just listed few domains only: fraud detection, social media, banking and finance, healthcare, space exploration, stock market. Want to go to Mars? Learn big data. So I guess if we talk about agenda, we have covered these topics. Okay, on this side, we have covered these topics. I hope everyone understood them. If you have any doubt, you can mention it in the comment section. Otherwise, have fun, enjoy your life, and if we stay alive, I'll see you in the next video. Bye.